Okay, hello everybody. Hope you have done with the first class. You have seen the video of the first class. Now we are going to move in the second class of yours. In the first class we had seen about the basics of very chemistry, that what is chemistry, what are the division of chemistry, what is atoms, molecules, etc. till the mixtures we had done. Now we are going to start with significant figures or significant digits or significant numbers, whatever you call significant figures, numbers, digits, numbers, you can say figures, you can say digits, anything. Now whenever we write some number, suppose I am writing it 6.022 into 10 to the power 23. All of you know this number, that is why I wrote this number. This is, what is that? That's the Avogadro's number. Okay. Now out of this, will all the digits that is written over here, 6, 0, 2, 2, 1, 0, 2, 3, all these are significant or not? That is governed by, so all numbers, all digits that is present in a number is not necessarily to be significant. There are certain rules, or you can say a set of rules, which tells us that whether the number is significant, whether the digit is significant or not. So let us know the sets of rules, then any number that will be given to you, you can very easily say that whether that particular digit in that particular number is significant or not, or how many significant numbers are present in or digits are present in a particular number. What are the laws? So the laws or the rules for finding the significant numbers are: the first one, all non-zero digits are significant. So first of all, we must understand out of this first rule. According to the first rule, 6 is significant, 2 is significant, 2 is significant, 1 is significant, 2 is significant, 3 is significant. That is according to this rule, but that's not everything. Let us go further, and then only we can come to the conclusion that which particular number is significant over here. Or let me take a simple version of it. Suppose I had taken this, I had taken a number like this, 06.0220. Okay, suppose this is the number. Now, so first, according to the first rule, what are the significant numbers? 6, 2 and 2, right? All non-zero digits are significant. Number 2, zeros preceding the first non-zero digit are not significant. So whichever is the first non-zero digit, so here the first non-zero digit is 6. So any number of zeros preceding that are not significant. So number of zeros preceding that is what? This zero is not significant. Who tells us? It is told by the second rule, right? Come to the third rule. Okay, zeros in between two significant figures, in between two significant figures or significant digits are significant. So if 0 is present in between two significant digits, then those zeros are certainly significant. Let us see it over here. 6 is significant, 2 is significant. So the 0 that is placed in between them is also significant. This is told by which rule? This is told by rule number 3. Yes? Okay. Next, number 4. Zeros at the end are significant provided provided they are placed after the decimal point. After the decimal point. Okay. So I have taken this number. Zeros at the end. At the end, this 0 is there. Is it significant? Yes, it is significant. Why it is significant? Because it is placed after the decimal point. If some number I write like this 660, this 0 is not significant because that is not placed after the decimal point at the end. Okay? But if I write 0.660, so obviously that 0 is also significant. Hope you understood that. Okay? So here this 0 is significant. Why this 0 is significant? According to rule number 4. According to rule number 4. That means the zeros at the end are significant provided they are placed after the decimal point. Rule number 5. Rule number 5. Any whole number has infinite number of significant digits. Infinite number of significant digits. What is the meaning of that? For example, suppose 2. If I write 2, how many significant digits are there? Obviously your answer will be 1. Fine. Can I write 2 as 2.0? You will say yes. Now how many significant figures are there? There are 2 because 2 is also significant, 0 is also significant. Why 0 is significant? Because that is placed at the end after the decimal point. Yes? Very good. Now I am writing this 2 can be written as 2.00. Now this is significant, this is significant. And you wrote in the third rule that zeros in between two significant digits are significant. So if these two are significant, this will be also significant. So how many significant figures are there? 3 significant figures are there. I can write it as this, 4, I can write it as this, 5, I can write infinite number of zeros. Okay, so a whole number 2, simply I have taken 2, it can be any whole number, can have or might have how many significant digits? Infinite number of significant figures. Clear? And the last one, the last set of rule, or last rule in the set is that the exponential terms are not considered as significant digits. What is exponential terms? 10 to the power. I wrote 6.022 into 10 to the power 23. Anything 10 to the power x, we are not going to consider them among the significant figures. So there is no count of the exponential terms in the significant figures. So if I ask you in this number how many significant figures are there, obviously you will say 1, 2, 3 and 4. Okay, 4 significant figures are there. Is it clear? So you can do it, you can just very nicely do that how many significant figures are present in how many, in a particular digit. So your homework for this will be, find the significant figures in the following numbers. Okay, or what are the number of significant digits in the following numbers? Number 1, 6.00. Number 2, 600. Number 3, 625. Number 4, 0629.00. Number 5, 500.2. Number 6, 732.02 into 10 to the power 2. Number 7, whatever, I'm just giving it like this, 888.3590 into 10 to the power 5. So can you do this? Okay, let's try. How many significant figures are there? You see, 6 is non-zero, so that is why it is significant. This 0 is significant. Why? Because it is placed at the end after the decimal point. And obviously, since these two figures are significant, so the middle one is also significant because that is placed in between the two significant numbers. So how many significant figures are there? This is 3, right? 3 significant figures are there. Next one, 6 is significant, but are these zeros significant? No, they are placed at the end, but this is placed at the end, but not after the decimal point. There is no question of it to be significant. So how many significant figure is there? Only 1. Okay. How many significant figure is there? Obviously 3. Remaining, you please try. Okay. Fine. So is it clear? It is clear about the significant figures? Fine. So we are going to move to the next topic now. Significant figures is over. Now we are going to move to the next topic. Next topic I should not say, just a concept, that scientific notation of the numbers. Now any number you write, how we should write it actually? We should write it in a scientific notation, scientific way. We cannot write any way. Suppose I had written 529.62. You can write it, there is no issues. It has got certain values, we can understand this. But this way, whenever we are writing, we are not writing in a scientific way. How to write the same number in a scientific way? We have to write the main number in between 1 to 10. So the decimal points has to be shifted. If I shift this decimal point over here, then only it is coming in between 1 to 10. So what is it? 5.2962. But since I had shifted the decimal point in the left hand side, it should be multiplied by 10 to the power 2. Yes. If you do so, then only it will become 529.62. This is the way of writing it accurately in comparison to this. This is not the scientific way of writing it. This is the scientific way of writing it. Or suppose if I take one number 0.00625. Obviously, this is not scientific notation. Scientific notation, what I told, the main number has to be in between 1 to 10. So you have to shift this decimal point over here. Yes. So if I shift the decimal point over here, it will be 6.25, and since I am shifting it 3 digits in the right hand side, so it will become 10 to the power minus 3. Is it clear? So that's how we represent the number, any number, in a scientific way. Clear? So scientific notation of a number is clear. So any number given to you and you are told to represent it by scientific notation, you can do it very, very easily. Right? The next one we are going to do is two terms. We must understand these two terms. One is accuracy, and the second one is obviously precision. So obviously they sound very similar. There is a very faint difference between these two terms, accuracy and precision. Okay. Now what is accuracy? What is precision? Please understand it. Suppose anything. Okay. Suppose this pen I made in my company. Suppose, and I know the length of this pen. Suppose the length I know of this particular pen is 4.2 inches. Suppose 4.2 inches. That's the actual length of it. Fine. Now I told you to measure this length, and I had given you the instrument for that. Any instrument. It can be a scale, it can be a capillary measure, whatever. There is any instrument you can use, and you can measure. Any apparatus you can use, you can measure the length of it. Okay. I had chosen 3 students. Student A, student B, and student C. I had given 3 different instruments. Same instrument, but 3 different one, and I told them to measure. Student A had measured it, and obviously 3 times I tell that measure it for 3 times. She measured it, and she found it as suppose 4.1, 5.0, and 3.2. 2. He found it. 3 different times he measured. He found once 4.1 inches, once he found 5.0 inches, once he found 3.2 inches. The second person, when I told he measured, and he measured and find it as suppose 5.2. Second time also he found 5.2, and third time he found 5.3. Okay, suppose he got this. Okay, now I will come to the third student afterwards. First let me come to this. So if I ask now student A that how much is the length of it, how much did you get? Obviously what he will do, he will take the average of this and he will tell me the length. So what is the average of it? You see 4.1 plus 5.0, that is 9.1, 9.1 plus 3.2, 9.1 means that is 12.3, 12.3 divided by 3 is how much? 4.1, right? So he is getting how much? He is telling me, sir, the length of this is 4.1 inch. Okay, fine. Now I asked the second student, you tell me that what is your length? How much length did you find of the pen? He will also take the average of these 3 and he tell me, sir, I got is almost equal to 5.2, so it will be something like 5.23. It will be something like 5.23. So 5.2 almost, if you take the average, it will come as 5.2. Now tell me, this is one's value, this is the second person's value. Who is closer to the actual value? Student A is closer to the actual value. So we can say he is accurate. But he is accurate by chance. He had measured the length of the pen with the same instrument 3 times. But 3 different times he got 3 different values far apart from one another. Means he is either he didn't perform the experiment clearly or he doesn't know how to perform the experiment. That is why he got the values all different, but by luck, by chance, his value is accurate to the original value. See the second student? His value, what value he told, is far away from the actual value. So he is not at all accurate. He is not at all accurate. But what is he? He has done his experiments very minutely, very seriously, and he knows the method and he did it. Maybe his instrument was wrong. Maybe somewhere some process was wrong. That is why he found the values that is deviating from the actual value. But all 3 times he got very similar values. This is called precision. This is called precision. If the student C gets 4.1, 4.2, 4.2. 3 times he got these values and I asked him that what is your value? He told me, sir, almost 4.2. So he is accurate as well as, you can see, precise. You understood what is accuracy, what is precision? So what is accuracy? Accuracy is closeness to the actual value. How much close the value is to the actual value is the accuracy. Clear? And what is precision? Precision is how much close the experimental values are. If the experimental values are close to each other means he is precise. He might not be accurate. But what is that in this particular case? He is accurate also, precise also. That is the perfect condition. The accurate and precise. Is it clear? So the definition, so the differentiation, the thin line of differentiation between the accuracy and precision is very clear to you. Okay, fine. So we'll move to the next one. Now, next one is what? We are going to study chemistry obviously, and very basically the chemistry is governed by certain laws, So we are going to know these laws, and today we are going to study just one law at this moment, and we'll try to do one simple numerical with that. Okay, so some basic laws of chemistry. Basic laws of chemistry. Mainly we are going to study 4 laws. The first one is law of conservation of mass, which all of you know. Conservation of mass. We will study that from the chemistry point of view, which we study today. Number 2, law of definite proportion, or we also call it law of constant proportion. Number 3, law of multiple proportion, and number 4 is law of reciprocal proportion. Today we are going to study with law of conservation of mass. I think all of you know this, what is law of conservation of mass. What does it say? That mass can neither be created nor be destroyed. Yes, the total mass of the universe is constant. Total mass of the universe is constant. Only it is changing the phases. The phases are changed. If we see it from the chemical point of view, if I talk about, so I'm rubbing it. If I talk about the chemistry, we know first thing that comes in our mind is chemical reaction. Chemical reaction means the complete chemical properties are changed by some changes. Clear? And that particular change is known as chemical reaction. So what happens over there? The reactants undergoing the reaction and is converted into products. Okay. Now, according to law of mass action, we know that mass can neither be created nor be destroyed. It will remain same. So, according to law of mass action, from the point of view of chemistry, we can say that in a chemical reaction, total mass of the reactants must be equal to total mass of the products. Okay? If it is following, means it's following the law of conservation of mass. So, let's just do one simple numerical. Let us write it down, that particular numerical. Okay? And let us just try to do it. It's a simple one. 10 gram of calcium carbonate. Let me write it. 10 gram of calcium carbonate on heating produces 4.4 gram of, on heating produces 4.4 gram of carbon dioxide and 5.6 gram of calcium oxide. Show that this experimental value agrees law of conservation of mass. Okay, so what did this say? It's very simple. Whenever we are going to do some numerical, we must frame it. What is framing? I am telling you. 10 gram, first we will read the question very properly. The English over here is the most important thing. Okay, then we will just frame it, and after that, don't get tensed by seeing the numbers. Numbers are nothing. Okay, we're just going to use those numbers, but that's all. So what is the question over here? 10 gram of calcium carbonate on heating produces 4.4 gram of carbon dioxide and 5.56 gram of calcium oxide. I am not going to show the amount. Amount is at last. First we must understand what they are saying. That calcium carbonate we are heating and we are getting carbon dioxide and calcium oxide. We will write down that reaction. Calcium carbonate on heating produces calcium oxide plus carbon dioxide. Okay, So what is the reactant over here? Calcium carbonate. What are the products over here? Calcium oxide and carbon dioxide. What we have to show? We have to show that this experimental value agree the law of conservation of mass. What is law of conservation of mass? The total mass of the reactants must be equal to the total mass of the product. So what is the mass of the reactant? See how much calcium carbonate was taken? 10 gram. So mass, this is called framing. Mass of reactant. Mass of reactant equal to how much? 10 gram. What is the total mass of the products? Calcium oxide and carbon dioxide. 4.4 gram of carbon dioxide and 5.6 gram of calcium. So total mass of the product equal to 4. How much? 4.4 and 5.6. So that is equal to how much? Again, that is equal to 10 gram. So what can we see over here? The total mass of the reactant is equal to the total mass of the product, and hence the values that is given over here, the experimental values that is given over here are in agreement with the law of conservation of mass. Okay, hope you understood today's class. Now next class we are going to move with law of constant proportion, law of multiple proportion, law of reciprocal proportion, and we are going to do the numericals for that. Till then, goodbye, stay safe, stay healthy.